You bought a powerhouse modeler and a great amp, but together they sound like a swarm of bees in a trash can. It's not your gear, it's your signal architecture. Welcome to the explainer, where we finally validate your frustration. I mean, if your delays sound muddy or that high-gain rig just won't stop humming, you are likely dealing with a routing failure, not a gear failure. And today, we're gonna fix it.
Okay, let's just dive right in. Look, every tone chaser knows this exact scenario. You drop serious cash on top-tier gear. We're talking a pristine tube amp, a flagship multi-effects processor, and you expect absolute magic, right? But instead, you just get this chaotic, washed-out mess. Well, this happens because plugging everything straight into the front of your amplifier completely ignores the fundamental physics of how your gear was actually designed to process sound.
So here is our roadmap for today's forensic deconstruction to get your rig sounding pristine. First, we're looking at the signal architecture. Then we'll walk through the practical build. After that, we'll tackle defeating ground loop hum. And finally, we'll uncover the gain staging secret.
All right, section 1, the signal architecture. Let's look at why the 4-cable method actually works in the real world.
The absolutely crucial point here is understanding the true anatomy of your guitar amplifier. It's not just one box, it's actually two distinct stages. You've got a preamp that generates your core tone and distortion, and a power amp that basically just makes it loud. Preamp effects, your overdrives, your fuzzes, wah pedals, those are designed to hit the front of the amp. But your time-based effects like delays and reverbs, those belong in the power amp stage via the effects loop. See, if you push delays into the front of a dirty amp, the preamp just distorts those echoes. The repeats compress into this awful, muddy wash. Splitting them up is the foundational logic of a professional rig.
Moving on to section 2, the practical build. This is our cable-by-cable guide.
The whole goal of the 4-cable method is to detour your signal so your real amplifier's preamp is treated like just another effect block inside your digital chain. So here's your definitive cable-by-cable guide. To pull this off, you need an amp with an effects loop and 4 really good quality shielded instrument cables. Cable 1 goes right from your guitar into your processor's input. Cable 2 goes from your processor's send jack into the front input of your amplifier. Now cable 3 takes the signal from your amp's FX send and routes it back into the processor's return. And finally, cable 4 goes from your processor's output back into your amp's FX return, which feeds the power amp. Boom, you're wired up.
Now, looking at the routing on something like a quad cortex, as an example here, you can trace exactly how the signal flows. It leaves the guitar, hits your digital overdrives, travels out to the real amp to get that authentic, gritty tube saturation, comes back into the digital realm for those pristine delays and reverbs, and then heads straight to the power section to be amplified. You are literally getting the absolute best of both worlds. Which brings us to section 3, defeating ground loop hum and the science of noise.
But okay, here is the harsh reality check. As soon as you hook all this up perfectly, you might get hit with this massive, annoying 60-cycle hum. Seriously, don't panic, and definitely don't blame your gear. This is just a limitation of physics, not a design flaw. It's an electrical phenomenon we need to isolate. What you're experiencing is called a ground loop. Because your multi-effects processor and your amplifier are both plugged into the wall, they both have their own path to ground. When you connect them using the audio cables we just talked about, you create a second, physical path between those grounds. This loop literally acts like a giant antenna, picking up stray electromagnetic noise and injecting a super messy hum directly into your audio signal. So what's the fix? Well, the ultimate fix for this is galvanic isolation. I know, that sounds incredibly complex, but it's really just a way of preventing direct electrical current from flowing while still passing your audio signal. It pulls us off via magnetic coupling inside an isolation transformer. By using magnets instead of a continuous piece of copper wire, it completely breaks that physical ground connection. It stops the hum dead in its tracks, leaving you with a perfectly clean signal. So, how do we actually implement this on your board? First, you have to identify the culprit. If your individual pedals are whining, you need an isolated power supply to stop them from sharing grounds. But if the hum happens when connecting the amp to the processor, you need a 1-to-1 audio isolation transformer, something like a Likla P-split or an EBTech hum eliminator, right on your effects loop to break that audio ground. Oh, and if your gear has a built-in ground lift switch, definitely engage it. Finally, for you high-gain metal players out there, use a sidechain noise gate like the Fortin Zool Plus and place it right after the noisy preamp. That'll intelligently kill the hiss without choking out the trails of your delays. All right, section 4, the gain staging secret. It's time to preserve that polish.
because we really have to talk about polishing the interior of our signal architecture so it doesn't sound thin or weak or lifeless. Have you ever plugged in your massive new rig, stepped back, and noticed your guitar suddenly sounds completely muffled, like it's super dark and just lacks that brilliant sparkle? Well, this dreaded phenomenon is known in the guitar world as tone suck. And once again, physics is the main culprit here.
Think about it. When you utilize the 4-cable method, you might easily be running 80 feet of total cable across that stage. Because standard instrument cables inherently act as capacitors. The longer the cable, the higher the cable capacitance. This essentially acts as a massive low-pass filter. It literally drains your highest treble frequencies straight to the ground before they ever even reach the speaker.
To defeat this cable capacitance, we use a buffer. A buffer is a specialized little circuit that takes your guitar's weak, high-impedance signal and converts it into a robust, low-impedance signal. This gives your tone the muscle to push through those massive cable runs without bleeding off any of that crucial treble. Now, most high-end modern processors actually have buffers built right into their inputs. But if you're building this with individual stomp boxes, placing a dedicated high-quality buffer at the very front of your chain is absolutely non-negotiable. But wait, there's one more piece to the puzzle. To keep your sparkle completely intact and avoid any nasty digital clipping, you also must balance your levels. Amplifiers typically run their effects loops at a really hot line level, while traditional guitar pedals expect a much quieter instrument level. You've got to dive into the global settings of your multi-effects unit and match these impedance outputs. Your ultimate goal is perfect unity gain, meaning when you properly balance the output of your pedal board with the input of your amp, your volume shouldn't drop, and it shouldn't aggressively spike. It should just sound seamlessly perfect.
So, what happens to your tone when you finally take control of the physics inside your cables? You unlock clarity, you get dynamic response, and you build a rig that actually empowers your playing instead of fighting it. Stop fighting the noise, master the flow, subscribe to the Tone Manual.